All right, so now let's take what we did with the gizmos and just apply it to other situations. So if DG is 4, JM is 3, and the perimeter of JKLM is 36, what's the perimeter of DEFG? So remember, this is the way I like to write it, like SF. S means scale factor for sides. We have SFP, scale factor for perimeter. All right, so remember, the scale factor of sides equals the scale factor for perimeter. So if I just take these two sides, I can say, well, the scale factor of DJ or DG and JM should be the same for the perimeter of JKLM and the perimeter, oh, excuse me, I misread. See, this is why it's good to write things. That should have been on the bottom. All right. See, it's important to be consistent, keep our work organized, so like DG on top, JM on bottom on both of them. All right, I had sides on the left side, perimeter on the right side. Again, there's multiple ways to set this proportion. Just keep your work organized and correctly cross multiply, because then we're gonna get 4/3 of this, and then we have this unknown perimeter, and then 36. And again, just get this far, and all you gotta do is cross multiply. You're gonna get 3P equals, I believe 144, but let me double check my work. Yep, divided by 3, and P I think is gonna be 48, but again, let me check my work and I was right. Cool beans. All right, the scale factor of corresponding side lengths of two similar computer screens is 13 to 15. All right, so we got two similar computer screens is 13 to 15. The perimeter of the small screen is 39. Find the perimeter of the larger screen. All right. So just like right 13 to 15. All right, so we have small over big. All right, so that's a side length 13, that's a side length 15. Well, on this left-hand side, well, it's telling me the smaller one's 39, the larger one's unknown, so that has to be on the bottom. We'll just call that X. All right, so on this case, my smaller numbers were on top, my bigger numbers were on bottom. Cross multiply, and again, I'm gonna have to use a calculator for this one. 39 times 15 is 585. Now I'm gonna divide both sides by 13, and truthfully, I don't know what that is. I'm gonna predict it's a whole number. I got a good feeling. Actually, it's gonna be 45. I can do that in my brain. So smart. Cool. All right. Last problem. Example, a town is building a new swimming pool. A town. Remember Hilliard renovated their swimming pool. That was the talk of the town. An Olympic pool is rectangular with a length of 50 meters and 25 meters. The new pool will be similar in shape, but will be only 40 meters long. Find the scale factor of the new pool to the Olympic pool. All right, so we're gonna do new over Olympic, cursive O. All right, now we can look, it's gonna be 40 meters long. All right, 40 meters long, and the other one is 50, so 40 over 50. So this is 4 over 5, also known as 0.8. Typically, most of the time I like fractions, but decimals aren't horrible either. So if we know the ratios, so notice how it doesn't tell us the width. What's the width of the new pool? It doesn't tell us that. And technically, not technically, we can figure out the perimeter of the Olympic pool and the new pool. Olympic pool, we know all the parts, but the new pool, we don't. So what do I mean by that? Well, let's find the perimeter of the Olympic pool. And that's gonna be 50 plus 50 plus 25 plus 25 equals 150. All right, and just like how perimeters and side lengths have the same scale factor, so the perimeter of the new pool over the perimeter of the old pool is equal to the length of the new pool over the length of the Olympic pool. All right, a lot going on there, but just keeping our work incredibly organized. So the perimeter of the new pool is actually what we're finding. We don't know that, so I called it X. The perimeter of the Olympic pool is 150, and we're actually using the scale factor we were using up in part A. So really, if you can get this far, incredibly good shape, just cross multiply, you're going to get 5x equals 600. Divide both sides by 5. And x, the perimeter, is 120. All right, that's the perimeter of the new pool. And that's pretty cool. We can figure out the perimeter without actually even knowing the width. We never calculated that. Powerful stuff. All right, that's it for today. Stay tuned for